Hi, everybody. Today we're going to talk about entropy. Entropy is the randomness of a system, how spontaneous a reaction will go, and it is a very important part of thermodynamics. So, as we already talked about, enthalpy is the amount of energy consumed or released in a system. Entropy is the amount of disorder or order or the lack of order in a system or randomness. And that's a very simplistic explanation. There's some videos below this one on the website that will allow you to look at some more detailed explanations. So entropy itself is a major part of the law of thermodynamics. And the laws of thermodynamics are pretty simple. So energy can either be created or destroyed, can only be changed into different forms. That one's pretty simple and stuff that we've done in grade 9. Where it comes into entropy, it's the next two. So the entropy of the universe is always increasing, or of a closed system. So it's always getting more and more random. And the only way to stop that randomness is to spend energy to put order back into the system, which is what our bodies do when we eat food and things like that. And then to have a perfectly crystalline solid at absolute zero is when you'll have zero entropy. So basically an impossibility because we can't get to absolute zero. Now there are some trends in entropy. The larger, more complex a molecule you have, the higher the entropy, okay? And if you compare that to smaller, less complex molecules, think of the randomest chance of things happening. The more larger, the more complex you are, the more moving parts there are, the more chances of things failing are. That's the idea behind this entropy. Gases have much higher entropies than liquid, which have much higher entropies than solids. And that should make sense. Gases are moving around. That's the kinetic molecular theory. They're bouncing around everywhere. Entropy increases as temperature increases. That should make sense too, because you get more randomness increasing as you have more things bumping into each other. And then large entropies changes happen at phase transitions. So when you go from solid to liquid to gas, or vice versa, that's when you get big changes in entropy. So there's a formula that kind of explains this, and it's called Gibbs free energy. And Gibbs free energy lets us look at how does entropy affect a system. So you can see here I have enthalpy, temperature, and entropy are oppositional to each other. One minuses the other. And the total energy that you get here from that is called Gibbs free energy. So when I take the enthalpy and I take the entropy and the temperature and I work out the equation, what I have left is the amount of energy that a system has to do work. So there's a couple things that will tell us if a reaction is favorable, meaning it's spontaneous, that favors the products, or unfavorable, meaning it's spontaneous or unspontaneous. Sorry, this should say here unspontaneous, and it favors the reactants. Okay, so if you have a positive delta H, so it's endothermic, and you have a negative entropy, it's got lots of order, what you're going to have is a positive delta G, and it's not going to be spontaneous. That should make sense. If you have something that is negative, so exothermic, you have lots of, for this next one here, you have lots of entropy. You get an overall negative number here, and a negative delta G, yeah, it is going to be spontaneous. It's going to favor the reactants. If both of these are negative, so exothermic but low entropy, what we're going to get is it's going to be spontaneous if you have a low temperature, but it's not going to be spontaneous if you have a high temperature. And then vice versa. If it's endothermic, it has high entropy, okay? It's going to be yes if the temperature is high and no if the temperature is low. So you can use this chart to solve whether something is going to have high entropy, low entropy, whether it's going to be spontaneous or not, how the entropy and enthalpy interact, and what the overall Gibbs is going to be. And then we can look at these here and figure out what it is. If delta H is less than 0, it's exothermic. If delta S is greater than 0, it's got lots of entropy, and delta G ends up being less than 0. It's got to favor the product and be spontaneous. Remember, this is non-spontaneous here. So delta H is greater than 0, so it's endothermic. You have very little entropy, it's less than 0. Delta G is greater than 0. It's got to favor the reactants. It's not going to be spontaneous. Hope this helps, and I hope this will help you go through lesson 2.3.